Here we're going to look at how the body goes about regulating blood glucose levels in order to maintain homeostasis. How the body goes about doing this is the pancreas is involved. That's responsible for monitoring blood glucose levels, specifically the Islet of Langerhans. Now, when we say homeostasis, this doesn't mean everything's a complete flat line. There can be continuous fluctuations, but they will occur within narrow limits. For example, when glucose levels are high, insulin will be released. When levels are low, glucagon will be released. We see a nice graph here where we're looking at our blood glucose levels in red and our insulin levels here in this bluish purple color. We can see that there are fluctuations throughout the day, but overall this is kept in a very tight range so our body can go about maintaining homeostasis. Looking at this in a pictorial sense, we have our pancreas here. We have two situations. One could be low blood sugar. That's our body's going to want to increase our blood sugar. Glucagon will be released, promoting glycogen breakdown in the liver. In contrast to that, if we have high blood sugar, we're going to want to decrease that blood sugar, and we're going to do that with insulin. Insulin's going to do two things. It's going to promote glycogen synthesis. It's also going to stimulate glucose uptake in tissue cells. And overall, that will lead to a decrease in our blood sugar. Now, when we have that high blood glucose, we call that hyperglycemia. So here would be our normal blood sugar levels, and we consume orange juice or something that has a lot of sugar, and now we are in a hypoglycemia state. Insulin is going to be released by beta cells in the pancreas, and that's going to initiate three things. Insulin's effects. First, it's going to trigger body cells to take up glucose from blood and utilize it in cellular respiration. It's also going to inhibit two processes. Glycogenolysis is one, where glucose is removed from the blood and stored in glycogen in the liver. It's going to inhibit that step. It's also going to inhibit amino acids and free glycerols that are not converted to glucose in the ER. So you may remember from our macromolecules, rough and smooth ER, this is glucogenesis. That will be also inhibited in a hyperglycemic state. Keep in mind, we're trying to get rid of some of this blood sugar. We're trying to store it. So this is what the body's going to go through and help trigger these events to help reduce blood glucose. In contrast to that, we have our homeostasis, and then we have low blood glucose. Well, glucagon is going to be released by the alpha cells in the pancreas, and that's basically going to do the opposite of what we just saw in the hyperglycemia state. Where insulin stimulates, this is going to inhibit, and where insulin inhibited, this is going to stimulate. So it's basically the reverse of that. And the whole goal here is to have blood glucose concentration increase to get us up to this range here after our hypoglycemic state. Looking at this, where we look at both parts together, we can see that here, where we have our stimulus of blood glucose levels. Here we have a cupcake. Beta cells in the pancreas release our insulin. That insulin signals the liver to take up glucose and store it as glycogen. Our body cells will also take up glucose. As a result, blood glucose levels will decline, reaching homeostasis. After a period of time, if blood glucose levels fall, alpha cells in the pancreas will release glucagon, and the liver will break down the glucagon to release glucose. Overall, blood glucose levels will rise, helping us maintain this homeostasis. So hopefully this kind of feedback system makes sense and helps develop a better understanding of how the body maintains blood glucose levels to keep homeostasis and allow the normal functions of the body to continue.